Hello everyone. Today we will start our video series on PySpark, which is a very useful tool for data engineering, data science, and machine learning related tasks. It's the Python API for Apache Spark. If we go to Spark website, we can see this information. It's a unified engine for large-scale data analytics. What is Apache Spark? It is a multi-language engine for executing data engineering, data science, and machine learning on single node machines or clusters. So we can use it on our local machines as well as on distributed systems. So it provides a very powerful scaling capability, as you can see. It's the most widely used engine for scalable computing, and it integrates well with the well-known frameworks, helping to scale them to thousands of machines. Apache Spark Core API is available in Python, SQL, Scala, Java, and R. We will use the Python API, which is PySpark. We can see the installation instruction using pip and also through Docker image, and then there is some usage on how we can read a CSV file and apply transformations and actions to generate the summary statistics. PySpark supports all of Spark's features such as Spark SQL, DataFrames, structured streaming, machine learning, and Spark Core and resilient distributed datasets. Let's get started and see how PySpark works. First thing, how we can install PySpark. It is included in the official releases of Spark available in the Apache Spark website. Python users can also install it from PyPy using pip install PySpark. If you want to install extra dependencies for a specific component, you can install by specifying the component. The default distribution uses Hadoop 3.3 and Hive 2.3. If users specify different versions of Hadoop, the pip installation will automatically download a different version and use it in PySpark. We can also download a Spark distribution from the site. After that, we can uncompress the tar file into the directory where we want to install Spark and set some environment variables to let the machine know where the files are. You can also sign up for Databricks Community Edition. All you need is an email address for sign up, and after you verify the email, you can access the Databricks platform. As you can see, it is free of charge. You do not pay for the platform, nor do you incur AWS costs where this is hosted. This is from the FAQ section on Databricks website. In the Community Edition, the users will have access to 15 GB clusters, a cluster manager, and the notebook environment, which is good for prototyping simple applications and learning PySpark. So thank you to Databricks for providing this very useful tool. To create a compute cluster, we can click on the compute in the left panel and then click on create compute. By default, the cluster name shows as your email address's cluster. You can click here to change the cluster name. You can leave the settings as is and click on create compute. Now, once we have an active cluster, we can create a notebook. For that, we click on New and select Notebook. We can also change the name of the notebook from untitled to something more descriptive. And then we can click Connect and select the cluster we created in the Create Compute step. Okay, let's look at PySpark's DataFrame API. DataFrames are 2D, rectangular, tabular, or sheet-like data structures, and we have covered these in great detail in the Pandas video series on my channel. In PySpark, DataFrames are lazily evaluated. What this means is that transformations on a data frame like select, filter, or group by methods are not executed immediately. Instead, Spark builds a logical execution plan and waits until an action like show, count, or collect is called. This optimization allows Spark to rearrange and optimize operations before execution thus improving performance. In PySpark, resilient distributed data sets are the core low-level data structures that enable distributed computing. PySpark DataFrames are a high-level abstraction of RDDs. When we apply transformations on a data frame, they are internally translated into RDD operation for distributed computing, leveraging Spark's optimizations. PySpark applications start with initializing Spark session, which is the entry point of PySpark. Spark session.builder.get or create method creates a single entry point to interact with Spark. It checks if a Spark session already exists in the environment. If it exists, it returns the existing session. If not, it creates a new one with default configurations. We can create a data frame from a list of rows using Spark create data frame and provide a list containing data rows. Here we can see the data types for each column in the data frame. We can also provide an explicit schema while creating a data frame from a list of rows. We can also create a data frame from pandas data frames. By default, PySpark uses lazy evaluation, meaning transformations on data frames are not executed immediately. They only execute when an action like show collect is called. However, when eager evaluation is enabled, PySpark automatically displays the first few rows of a data frame. If we disable the eager evaluation and check the data frame, we can only see the data frame with column name and data types as before, and not the data rows as with eager evaluation. Here we need to perform an action such as use show method to display information. The rows can also be shown vertically. This is useful when rows are too long to show horizontally. To do so, we set the parameter vertical to true. Like in pandas, we can check the column names using df.columns. We can also use print schema to see the data frame schema. Like in pandas, we can use the describe method to compute the summary statistics, and we can also use the select method to select some columns. Spark applications run as independent sets of processes on a cluster coordinated by the Spark context object in your main program. It's called the driver program. The driver program is the process running the main function of the application and creating the Spark context. To run on a cluster, the Spark context can connect to several types of cluster managers, either Spark's own standalone cluster manager, Yarn, or Kubernetes, which allocates resources across applications. Once connected, Spark acquires executors on nodes in the cluster, which are processes that run computation and store data for your application. Next, it sends your application code to the executors. Finally, Spark context sends tasks to the executors to run. Spark data frames are distributed across multiple worker nodes in a cluster. When the collect method is called, all the data is fetched from the executors and loaded into the driver's memory. Remember, this can lead to an out-of-memory error if the dataset is too large because the driver node may not have enough RAM to hold the entire dataset. To avoid the out-of-memory exception, we can use take and tail methods to return the first and last n rows respectively. These return as list of row objects. We can use toPandas method to convert back to pandas data frame to leverage pandas API. It is important to note that toPandas also collects all data into the driver side. That can easily cause an out-of-memory error when the data is too large. PySpark DataFrame is lazily evaluated, and simply selecting a column does not trigger the computation, but it returns a column instance. These column instances can be used to select the column from a data frame. We can also assign new column instances using withColumn. We can use filter method to select a subset of rows. PySpark supports various user-defined functions or UDFs and APIs to allow users to execute Python native functions. UDFs in PySpark allows users to define custom functions in Python and apply them to data frames. In this example, we directly use the APIs in a pandas series within pandas native function. Another example is DataFrame map in pandas method, which allows users directly use the APIs in a pandas data frame without any restrictions such as the result length. The way this code works is that PySpark DataFrame is split into partitions. Each partition is then converted into a pandas data frame and applied the pandas filter function. Then this filters rows where column A is equal to 2 in each pandas data frame and then yields the modified partitions back to PySpark as a data frame. And finally, we display the result. PySpark DataFrame also provides a way of handling group data by using the common approach, which is a strategy based on split, apply, and combine. It groups the data by a certain condition, applies a function to each group, and then combines them back to the data frame. We create a new data frame and then group by color and apply average to the resulting groups. We can also apply a Python native function against each group by using Pandas API. The way this code works is that it groups the PySpark data frame by column color, then it converts each group into a Pandas data frame, then it computes the mean of V1 per group and subtracts it from V1 values, and then returns the transformed data keeping the same schema. Finally, it reconstructs the PySpark data frame and displays the result. We can also co-group two PySpark data frames based on a common column and apply a function using apply in pandas. What this code does is that it groups both data frames by the ID column, then it co-groups the two data frames based on ID, converts each co-grouped subset into pandas data frame, and then applies the merged ordered function to merge them while preserving order. And finally, it converts the result back to a PySpark data frame with the defined schema. We can use write CSV method to save the files and then read CSV method to read the file again. Similarly, we can use a read Parquet and write Parquet for reading and saving Parquet files, and read ORC and write ORC for reading and saving ORC files. DataFrame and Spark SQL share the same execution engine, so they can be interchangeably used seamlessly. This command registers a data frame as a temporary table named table A, which can be queried using SQL within the same Spark session. Here we want to know the number of entries in the table. Similarly, we can run another SQL query to get data where color is red. In addition, UDFs can be registered and invoked in SQL out of the box. These SQL expressions can directly be mixed and used as PySpark columns. In the code, we import expression which allows writing SQL-like expressions as strings in PySpark. Let's do a project now in which we will load the anxiety attack dataset into Databricks Community Edition. The dataset is a CSV file which is already downloaded from Kaggle to my local machine. We will use the knowledge gained from the previous slides and perform some operations to explore this dataset. This Kaggle dataset has a good mix of categorical and numeric columns. There are also other videos on EDA on my channel. You can refer to these videos if interested in knowing more about EDA. Let's create a table in Databricks Community Edition using file upload from our local machine. We can click on New and select Table. We can create a new folder if required or use the default location. Then we can drop the files here or click Browse to select the file. We can see the file location where CSV is stored. We can create a table using our table preview functionality, or you can create a table from within a notebook by clicking the button on the right. Tables and views are fundamental concepts in Databricks for organizing and accessing data. Once clicked on Create Table with UI, it asks to select a cluster to preview the table. Then click on Preview Table to see the table. We can check if the first row is header, if we know the file contains headers or column names, and we can also check infer schema such that it is automatically inferred from the file. Otherwise, we can update this information in the table preview manually. Then we click on Create Table, and now our table is created and we can use it in our notebook and run some PySpark commands. First, we need to get an existing Spark session or create a new one. Then we can use Spark SQL to add the first 5 rows of gender and occupation from the table. The table in this case is the one we created in the previous step. We can use group by and count to find the total number of entries for each gender in the data. We can also use describe to get the summary statistics on the table or on some select columns. Here we are setting the parameters vertical to true because rows are too long to fit in the display nicely. It shows the summary statistics and then the corresponding values for each column. We can use the Spark table to convert the table to data frame and then use the describe method on the data frame to get the summary statistics as before. We can use filter method to select a subset of rows, and we can use the group by to create groups from the data frame and compute some statistics on these groups. Here we apply the group by on gender and occupation columns and then calculate the total number of values in each group using the count method. Okay, I'll stop this video here. Now that you know how to load a CSV to Databricks Community Edition, give it a try and explore more functionality of PySpark by using it on your projects for a more detailed EDA. The more you will practice, the more you will learn. Thanks for watching. In the next video on PySpark, I will show you how to use Pandas API on Spark. If you like this video, please press the like button and share. Also, don't forget to subscribe to my channel. Thank you.